Now let's look at a new type of function that is related to the exponential function. It is called the logarithmic function, and it is a family of functions actually. So let's start with just by finding some inverses of some functions. So here we have a function that's linear, and it would pass the horizontal line test, so let's find its inverse. So to find its inverse, we replace f of x with y. Then we swap x and y, so we would have x equals y plus 2. And so now solve for y, and we would have y equals x minus 2. Therefore, f inverse of x equals x minus 2. Now this makes sense because what would undo addition of 2? Subtraction of 2. Let's look at this one. Again, replace f of x with y. Y equals 2x. Swap x and y. Now solve for y, so x over 2 would equal y, and therefore f inverse of x equals x over 2. Again, this makes sense because what would undo multiplication of 2? Division by 2. Now what would be the inverse here? We would have y equals the square root of x. Swap x and y. And now to undo the square root, we need to square both sides. Now we would have to be careful because here x would have to be non-negative because of this statement right here. The square root of y only returns non-negative values. So this tells us that f inverse of x equals x squared, where x is bigger than or equal to 0. What about this? We have y equals 2 to the x. Let's switch x and y. Now we need to solve for y. What would we be able to do to isolate the y here? We have a problem. So to deal with that problem, let's go ahead and introduce the logarithm. So if a is bigger than 0 and not equal to 1, that should sound familiar. It was the same as what we did with exponentials. Then y equals log base a of x means a to the y equals x. So notice the base of our logarithm is the base of our exponential. In our exponential, y was our exponent, but notice that the exponent has been separated from the base. So if you want to separate a base and its exponent, the logarithm does that. Now, what's the domain of a logarithm? The argument cannot be negative and the argument can't be 0. So x is the argument in this case. It must be bigger than 0. So now let's return to f of x equals 2 to the x. So we have y equals 2 to the x. If we swap x and y, we'd have x equals 2 to the y. Now, how do we isolate y? Let's use the logarithm. The base of our logarithm will be the same as the base of our exponent. And remember that the logarithm separates the base of 2 and its exponent y. So log base 2 of something will equal y. What is the argument? It will be x. So 2 is the base, y is the exponent, and it is separated from the base. Now here log base 2 of x. This is not an exponent on the 2. This is log base 2 of x equals y. Now what's this mean? This is f inverse. So f inverse of x equals log base 2 of x. So notice the exponential base a and the log base a are inverses. And there are implications there. That means that they would undo each other. So let's take a look at an exponential equation and rewrite it as a logarithm. So log, what will be the base? The base is the same as the base of the exponent, so log base 3 of something equals something. Well, remember that the base and the exponent get separated by the logarithm, so the exponent should go over here. So log base 3 of 243 equals 5. Likewise here, we're going to write log. What's the base? The base is going to be the same as what you see in the exponential. And log base 9 of something equals the exponent. Log base 9 of 2 equals the exponent. What will be the what will be the base here for the logarithm? The base is going to be the same as what we see in the exponential. So log base 27 of something equals our exponent, because the logarithm separates the base and the exponent. Now we're going to try this one. Go ahead, pause the video, and try to rewrite this so that you see a logarithm. What will be the base of our logarithm? Log base a. Of what equals what? Well, the right-hand side will be the exponent. Log base a of c equals b. Now let's go ahead and take a look at going the other way. This logarithm has a base of 25, and we want to write an exponent. So 25 is the base of our exponential. What will be the exponent? It's on the other side of our equal sign. So 25 has been separated from its exponent. So 1/2 is the exponent. So 25 to the 1/2 is x. Log base c of 5 equals 2. Well, the base of our exponential is c. Its exponent has been separated from it by the logarithm, so c raised to the second power equals 5. Now, if our logarithm is base 10, we don't write the 10. So log base 10 of x is not something we write. We will write just log of x. And likewise, instead of writing log base e of x, we will write that as ln of x. So ln is Latin, and that is why the L is first. It stands for Logarithmus Naturalis. So in Latin-based languages, you will typically see the adjective after the noun. So Logarithmus Naturalis is modifying the logarithm.